Hello and welcome to this webinar where we're going to be discussing FRMCS, or the Future Railway Mobile Communication System, and also the UIC Rail Academy. Now, as many of you will know, the rail industry today uses a technology called GSMR, which is actually a version, a derivative of the 2G GSM technology. Now, what isn't widely known is that the GSMR technology, or the standards for GSMR and the standards for FRMCS, are actually authored by the UIC, or the International Union of Railways. Now, the UIC is a global organization that happens to be headquartered in Paris. Now, this webinar is going to be split into three sections. In the first section, I'm delighted to announce that I'm going to be joined by Jean-Michel Evangelou, who's from the International Union of Railways, and he will be joining us from the UIC headquarters in Paris. And he's going to talk to us about the new developments at the UIC with respect to FRMCS. And he's also going to talk to us about the new UIC Rail Academy. Then I'm going to have a fireside chat with Wray Castle trainer Les Granfield, who's an expert in this area. Les and I are going to discuss the type of issues that you're likely to face when designing and deploying a new FRMCS system in the context of an existing GSMR system. And finally, I'm going to be joined by Marku St. John, who's going to talk to us about the various modules and training courses that Wray Castle has available, which will help you upskill your teams, etc., in preparation for the exciting new world of FRMCS. So without further ado, I'd like to introduce and hand over to Jean-Michel Evangelou, who joins us from the Paris headquarters of the International Union of Railways. Over to you, Jean-Michel.
Good morning. My name is Jean-Michel Evangelou. I am the Director of Telecom, Signaling and Digital Application, as well as the Director of Financial Control and Project Operation in UIC, the International Union of Railways. It is a great pleasure to be with you today in this seminar presenting the UIC Rail Academy and particularly focusing on FRMCS. First, I would like to share some elements with you regarding the new concept of UIC Rail Academy, just unveiled in June of this year. Through the permanent dialogue that UIC maintains with all its members throughout the world, and also with all the other actors of the railway sector, we realized that there was a strong demand for some high-quality training for various railway domains, different from one region to the other. Sometimes it is about new technologies, and sometimes it is about what we can call legacy railway technologies. It is true that UIC, in its general role of technical body for the railway, developed over the years different action of training, responding to specific demands from some railway domains, like the high-speed domain, for instance, or from some regions where there was the expression of a certain need at a certain time. This was made possible by the existence of UIC of around 150 technical groups, forums, or platforms populated with experts knowledgeable on the various aspects of the railway systems or services. But I need to say here that we did not organize this in a framed way till now, and that we did it in a reactive way. These are the basic reasons why we therefore decided to build a specific new UIC service, the UIC Rail Academy, with the ambition to meet the needs of our members, of course, but also of the other actors of the railway sector more largely. To reach this target, we felt that we would be more relevant and more efficient if we had the possibility to rely on a recognized expertise, because the activity of training in itself needs certain competencies, methodologies, experience, and tools. This is why we have decided to partner with a recognized company in the domain of professional training, the Wray Castle company. We had then several discussions and exchanges with Andrew and his team over the last period, And it is very interesting to state that we rapidly agreed on the logic, the objectives, and the content of this partnership. And the proof point somewhere is this webinar that we are doing together today. Of course, the UIC Rail Academy will grow step by step, including more and more domains going forward, what we will call training sections in the global UIC Rail Academy. But it was necessary to have a first well-defined and content-relevant section to really start this academy. And which railway domain could have been more adapted to the case than the telecom domain, where UIC is a central actor with its 20 years leadership on GSMR and now its leadership and program development of FRMCS. This is why we focused with our partner Wray Castle, whose fame and professionalism regarding telecoms in general is absolutely recognized, on developing a sound telecom section to start the UIC Rail Academy, with a large content on all the aspects of mobile telecoms, GSMR, 5G, and even their application in ETCS signaling. Obviously, bring in this section the latest knowledge and specification elements regarding FRMCS, the future railway mobile communication system, for which each day makes that it is less and less future. I will stop here. You will get in this web seminar a lot of information regarding the training content of the telecom section of the UIC Rail Academy, and also, because this is totally linked in the background, about FRMCS status and progress. I want to wish you a very fruitful seminar, and I thank you very much for your presence and your attention.
Okay, thank you for that, Jean-Michel. That's very, very interesting. So now I'm delighted to be joined by Les Granfield. Les, if GSMR is working so well, why change it?
Yes, thank you, Andrew. Well, yes, GSMR is working very well. It does exactly what it was designed to do, and it's still being rolled out in a number of European countries. But unfortunately, the major manufacturers of the equipment have declared their intent to cease supporting their products from the year 2030 or about 2035. So in the future, it's going to be quite difficult to obtain spare parts, and that's going to damage the integrity of our mission-critical network. FRMCS offers us a unique opportunity to build a radio communication systems for the railways that's going to be future-proofed. The idea is we are going to develop applications which are going to be independent of the communications network. The issue with GSMR is the functionality is baked into the system, it's baked into the hardware, it's written into the software, and it's very, very difficult to introduce new applications or services. But with FRMCS, if we focus on developing applications and ensure those applications interface to any transport network, then the system will be future-proofed.
Thank you for that, Les. So, Les, I've heard much discussion that the new FRMCS standard is based on 5G. Could you explain the context to what I've heard?
5G is possibly the obvious choice for a transmission communications technology. When the FRMCS project began way back in 2012, we were in the middle of rolling out 4G LTE, and indeed 3GPP had developed the mission-critical standards which can run over a 4G network. However, some years have passed by now, and we now see commercial operators deploying 5G. So it therefore makes sense that we should adopt 5G as the transport technology for FRMCS.
So Les, if you're thinking of deploying a new FRMCS network whilst you have a GSMR network in place, what do you think are the important factors that one should consider in doing that? Is it important, for example, to understand about the GSMR network? You know, why do you need to understand about it? It's going to be taken out. It's gone obsolete. Surely it's not important.
Well, clearly, GSMR will have to coexist with FRMCS for a number of years. We have this migration period because the railway industry is a massive industry. There are thousands and thousands and thousands of cab radios, for example. There are thousands of base stations. It's operational across the whole of Europe. And not all countries will actually be able to migrate across to FRMCS at the same rate. So engineers working on the system will need to have detailed understanding of GSMR, and they need to know how FRMCS will utilize 5G and how we're actually going to make those two systems work side by side.
So Les, in order to deploy this new FRMCS system, what if any new spectrum has been made available to effect this change?
Well, currently the GSMR spectrum is at about 900 megahertz. There's two blocks, each is 4 megahertz wide. One is used by the base stations to transmit down to the mobile devices, and the second block is used by the mobiles to transmit back to the base stations. But unfortunately, the smallest 5G radio channel is actually 5 megahertz wide, so it won't fit into the existing spectrum. So a decision has been made at a European level to allocate a further 1.6 megahertz spectrum to the bottom of the existing GSMR spectrum. So that will then give us a total of 5.6 megahertz of spectrum, and we could actually then fit a 5 megahertz 5G channel in that spectrum. That will leave us 0.6 megahertz or 600 kilohertz of spectrum in which we could deploy perhaps two GSMR channels. But that may not be sufficient. So at a European level, a further 10 megahertz of spectrum has been allocated at 1900 megahertz. And we could easily fit a 10 megahertz radio channel into that spectrum, and that would be ideal. But one of the problems with 1900 megahertz being a higher frequency, its range will be somewhat less. Typically, if you double the frequency from 900 to 1900 approximately, you effectively half the range. So to cover the same length of track with a 1900 megahertz system, we will potentially need twice as many base stations, and clearly that's going to be quite an expensive undertaking.
When you say expensive, why, Les?
It's going to be more expensive because you need twice as much equipment. We can co-site some of the 1900 megahertz with the existing 900 megahertz base stations, but then again you've got to consider putting new antennas on the masts. We've got to make sure we have enough capacity in terms of transmission capacity, power supply capacity, air conditioning for the equipment located on those co-sited positions. But overall, potentially it will become more expensive. I noted at the UIC conference that was held in the summer, the Huawei suggested that maybe we don't need to worry too much about reducing the range of a 1900 megahertz by perhaps deploying smart antennas. And also 3GPP have looked at one of the limiting factors of LTE and also 5G, and that's the small amount of power which the handset can generate. It's only 200 milliwatts. Well, when you consider a cab radio for GSMR, it can generate 8 watts of power. That's a huge difference. So what 3GPP have done is to try and address that issue to a degree, is to introduce a new high power mobile, which can generate about 1.25 watts. Clearly not as good as 8 watts of power, but it will go some way to help increase the range of our 1900 megahertz cells.
But just to summarize, what you've just said, and correct me if I'm wrong, is that the frequencies of the new spectrum is higher, so the range is shorter, and the power level that one is allowed to use is going to be lower. So what you've articulated there is a double whammy, actually, correct? That you've got a higher frequency, so shorter range, and a lower permissible power.
You're quite correct, Andrew. I was going to use the same term myself. It is a double whammy effect. We are increasing the frequency, so that compromises range. We are limited to using less transmit power, so that also compromises range. But potentially, if we engineer this carefully and if we take advantage of beamforming, smart antennas, we may be able to claw back some of that lost capacity.
The other thing that I've heard, Les, in discussions is quite a lot of discussion about sharing facilities. And some people regard that comment as sharing facilities with public network operators. operators, and what they mean by that, or what they interpret by it, is effectively using the facilities of the public network operator. There are other people who interpret that discussion as actually the public operators using facilities that the rail operators may have. Now, as we migrate into this new FRMCS world, how do you think that might impact the existing operators, the existing assets that either a public mobile operator may have, or indeed a rail operator may have or may need to build?
Yeah, one of the problems about employing the services of a commercial operator is perhaps the commercial guys won't be too keen on providing cellular coverage in some of the more rural locations. Trains run extensively across country. In those rural locations, there is going to be, very few potential subscribers, and commercial operators are not going to generate a lot of revenue from those locations. So it will be difficult to perhaps persuade them to do that. The other issue is the fact that we're building a mission critical network, and that has some legal responsibilities. And maybe the commercial operators might not feel too comfortable about getting involved with these sort of legalities of supporting a mission critical network. One of the beauties of working with the commercial operators, of course, is they've got plenty of spectrum. Maybe we can borrow some spectrum or buy some spectrum from the commercial users and give us more capacity. Or maybe if those commercial users are building a 5G network, one of the beauties of 5G is it supports things such as network functions virtualization, software-defined networking, and these are ideal tools to be able to perform network slicing. Network slicing is where we sort of divide the network up to support different applications or different use cases. And maybe a commercial operator might build a network slice specifically for railway operations that addresses the needs of the railway environment.
Yes, and I think, Les, it's also true that in this discussion, one mustn't forget the possibility of actually the public operators, commercial operators, coming into facilities that are provided by the rail industry. So this may actually become another interesting revenue opportunity for the rail industry, which it does sound as if it's going to have quite a significant investment in physical infrastructure, sites and towers to support FRMCS anyway, and it may well be that this is an opportunity to bring the commercial operators into and along the rail network. And certainly as a consumer, I think we've all experienced, I've certainly experienced a lack of coverage in certain areas, and the wish that perhaps we all wish that mobile operators were covering certain areas.
I agree with that, Andrew. It will work both ways. If we can encourage the commercial guys into the railway environment, station platforms and such like, then they can provide better 5G coverage for their customers. So the general public will benefit, and it's a case of give and take. I think both parties will benefit from mutual cooperation.
Now, Les, we've also spoken here about potential changes in the physical infrastructure that a rail operator actually may need or will need to implement. So if we think about this, from what we've said so far, we've got a situation where we're going to have to build, or the rail operator is going to have to build more towers, which means more transmissions, more masts, etc., to cope with the different radio environment. Are there any other things that they're likely to have to do in that environment? For example, will the existing masts need to be looked at? I mean, do you think they're strong enough for the existing sites? Will there be any impact on the existing sites, do you think?
That is an important consideration. I think when those original sites were built, maybe we didn't even consider putting additional antennas on those masts, and maybe they were designed to just simply carry the intended payload. If we're going to be co-siting FRMCS at 1900 megahertz, along with our 900 megahertz systems, that will require additional antennas placing on the mast. So we would need to check the integrity of the masts. Have they got sufficient wind loading? And of course, at the bottom of the mast in the container where the base stations are located, do we have enough adequate air conditioning? Have we got enough power capacity, transmission capacity? So there's a lot of thought that needs to be going into the co-siting of different types of equipment, and even the potential interaction between GSMR equipment and an FRMCS equipment. There has been a lot of co-siting work done by the commercial operators in years gone by, but we've never co-sited GSMR along with 5G. This is new and needs investigating.
One of the things that strikes me about this future transition, and I know one of the reasons why the UIC has created the UIC Rail Academy, is that on the face of it, we have an industry, the rail industry, which has been very successfully deploying GSMR, which is a 2G technology, which and that industry now needs to have an understanding of 5G. There's an enormous gap here. You've touched upon some of the things, the reasons for those gaps, things like the 5G network sharing and network slicing. Is there anything else you'd like to highlight about the gaps between this technology that people will need to understand to upskill themselves in order to successfully design and deliver an FRMCS network?
Well, I think clearly the network architecture is completely different to what we've seen with GSMR. So we need to get a much more precise understanding of how the 5G network is built, how the radio network is attached to the 5G core, and what we're using across the radio interface between the base station and the trackside equipment, the cab radios. It's a completely different air interface. We've never seen this type being used in the railways before. It uses a technique called orthogonal frequency division multiplexing, and it's a relatively new technology. We have been using it for 4G LTE, but when it comes to engineering, fault finding, and even in just planning and optimizing the network, it will require a different approach.
Okay, thank you for that, Les. That's been a very comprehensive overview. I'm now joined by Marku St. John, who's going to tell us about the various Wray Castle modules and training that's available to upskill both yourself and your team. So welcome, Marku.
Thank you, Andrew. Hello, my name is Marku St. John from Wray Castle, and I'm going to spend now a few minutes with you to talk you through the training programs that are available within the Telecoms section of the UIC Rail Academy. So within the Telecoms section of the UIC Rail Academy, there are essentially 4 different training programs available. So first of all, we have our single course self-study online. So our self-study online training program are for those of you that want to study at a pace and time of your choosing. You can focus on one particular area, and we have all of the rail radio communications courses available as self-paced, as well as a whole catalog of other telecoms training. Within the self-paced distance learning environment, you will also have access to a live trainer to support you with any questions you have about the topic. And you'll have a license to the access to the virtual learning environment for 12 months. The next program is instructor-led on a single course. So we will have a regular schedule of live instructor-led training, either virtually online or in a classroom. The next live instructor course will be taking place at the UIC Paris headquarters on the 4th and 5th of October. The next section is the Diploma in Rail Radio Network Engineering. So for those of you that are looking for a comprehensive training program for all of the elements within rail radio network engineering. So this is a self-study online program. In this, you will have access to 5 important courses, 2 foundational courses, including Introduction to Telecoms and Radio Principles, and then 3 focused rail radio communications courses, GSMR Engineering Overview, ERTMS, ETCS for radio engineering, as well as our FRMCS engineering course. Then finally, we have our Telecoms Collection. This is our flagship training program, where you will have all of the courses within the Diploma in Rail Radio Network Engineering, as well as access to 5 more advanced telecoms training courses important for the rail industry. So these are 2G to 5G mobile technologies, 5G engineering overview, GSM air interface, introduction to radio, and microwave link planning. In addition to all of this self-study training, we also provide within this program access to the live online instructor-led training of instructor-led FRMCS training. In total, the 10 courses are 228 hours of learning. You can head over to our website to find more information about any of these training programs at wraycastle.com/UIC. Here you'll find more information and further links. You'll also find a schedule of live instructor-led training. And you can also download detailed brochures about all of these, as well as detailed course descriptions for any of the courses. So for FRMCS Engineering, this will give you a summary of the program and go through all of the topics that you will cover throughout the program. So I hope this webinar has been informative and interesting. And if you have any questions about any of the courses or programs that we've talked about throughout, please don't hesitate to reach out to myself directly or at the contact details shown on the screen. Just to mention, in addition to all of the training programs we have available, we also provide customized training if it's a larger organization, a team of people that you want to train. So please reach out to us directly to discuss that further. Again, we have FRMCS engineering taking place at UIC Paris on the 4th and 5th of October. And with any of the training that you get, including the diploma in Rail Radio Network Engineering, you will receive an official UIC certificate. So thank you for joining us today and look forward to seeing you on one of our courses in the future.
So thank you for that, Marku. And thank you everyone else who's participated in this webinar. Special thanks, of course, to Jean-Michel Evangelou from the UIC, to Les Granfield, and of course to Marku St. John. And of course, a big special thank you for watching this webinar. I hope you've enjoyed it. Thank you for staying to the very end. I, of course, personally hope to be able to meet you in person, either at one of our training events or at an industry event at some point in the future. Thank you for joining us. If you have any questions or inquiries, please contact us at the email address that's shown on the screen or will be shown on the screen in a moment. Once again, thank you very much, and I hope to meet you in person soon.